This is Jason with net.academy/LA Networks. As always, appreciate you joining today. We'll be going through a live demo. If you know anything about me, or if you've seen some of my previous trainings, you know that I'm a huge fan of demos in general. I like getting hands-on. I think that's how I personally do my best learning. You know, of course, there's lots of different ways people might learn. I really enjoy doing hands-on. It allows me to take that theory and then put it down to something concrete, and it just makes a connection for me. So today we're going to be going through, we're going to create internet gateways. We're going to create customer gateways, NAT gateways, virtual private gateways, you know, all the things that we've been talking about. So it should be a pretty good one. As always, if you're enjoying our content, please consider giving us a like and a subscribe. You can click the bell icon if you need notifications. And if you have any questions, please just leave them down below. And that should about do it. Let's go ahead and hop in. All right, let's hop right in here today and take a look at this lab. So it's pretty straightforward. And if you followed the previous two sessions, this should probably make some sense. It's simple, but not necessarily easy. Just depends on your experience, right? So let's just walk through at a summary level what we're going to do. I have pre-created a VPC and 4 subnets. That's really all I've done for the pre-work. If you need to see how a VPC is created, how subnets are created, and so forth, we have a previous demo that you can go look at where I go through all that. In this case, I've already got that pre-created. So what are we doing? Well, 2 of our subnets are what we call public. 2 of our subnets are what we call private. I want to start right there and say this is a very common AWS design architecture, but it may or may not fit your particular enterprise. I see a lot of enterprises that don't want to just route directly to the internet from a VPC. They may want some, in fact, I'd say almost all enterprises I run into want a centralized internet control point where they can put their security controls in. They're not just going to rely typically on AWS security controls, things like security groups or NACLs, etc. So we might talk about that, putting in a network appliance like a firewall or something, and what that might look like. I can't really demo that. That would cost money because I'd have to actually have a license and all that kind of stuff. But we can definitely talk through that in a much later session. So, but nonetheless, AWS has this kind of architecture all the time. So I want to go through it, make sure you're familiar with it. And it's not an invalid architecture, but it may not fit your needs is all I'm saying. So we have 2 public subnets. We have 2 private subnets. The subnets are in different availability zones. We have 3 gateway objects. We're going to have an internet gateway up there at the top, a NAT gateway up in the public subnets, and then we have a virtual private gateway or private virtual gateway, sorry, or VGW down at the bottom, right? We're going to create 2 route tables in this case. And you could create 4, you could create 1. 1 would probably not be a good idea with public subnets, but you know, what you can do and what you should do, you know, there's a gap there. But in our case, we're going to create 2 route tables, neither of which will be main route tables. And the public route table will have a default route that points out the IGW. The private route table will have a default that points to the NAT gateways. You'll see that those NAT gateways are set up in the public subnets. Why? Because our definition of a public subnet is something that has public IP addresses, aka NATs, right? And so we'll set up a NAT gateway. I have 2 pictured here. We'll probably just set up 1 to simplify things. You know, this is a demo, not a live environment. So default route will point to a NAT gateway. And then we will have a 10/8 route, which points back to the VGW. The VGW we will deploy and attach to the VPC. And the VGW, we will walk through what it's like to set up a VPN connection, to download the configuration files, etc. However, I don't have an actual VPN, so we'll program the route. We'll pretend that we have a VPN. I'll walk you through all those steps, but we're not actually going to have an on-prem VPN. I just want you to understand those concepts. Hopefully that makes some sense. Let's go ahead and hop into the console. Okay. Just for a quick overview, you can see I've already created the VPC. Here's my CIDR block, which you can see. And if we come down here, we'll see here are my 4 subnets. Here are my 4 CIDR ranges assigned to each of those subnets. This all matches up pretty well with the drawing that I shared earlier. So the first thing we're going to do is actually go create those gateway objects. And we're going to start with the internet gateway. So you can see down here on my virtual private cloud working frame, I've got internet gateways right here. There are none right now. We're going to go ahead and create one. We'll give it a name. Right. Okay. After that, we need to attach it to a VPC. So I go ahead and I select my VPC and I go ahead and attach. Okay. We're not actually routing anything out that internet gateway yet. By the way I like to do this is I create my gateway objects first. Then I create and configure my routing tables. Why is that? That's because in my routing tables, I need to point to the gateway objects themselves to complete the routing. So even though it looks like, if we kind of just look at the menu, it looks like I do VPCs, subnets, route tables, then gateways. I don't like doing that because my route table has to get retouched once I create the gateway object. So I create all the gateway objects first. Our next step is going to be creating the virtual private gateway. And that is under the VPN section, right? So you can see here's my virtual private network. You can see I have customer gateways and virtual private gateways. Not mentioned on the slides, but we will have to create a customer gateway as well. It's the only way to create a VPN, which, you know, we want to walk through the process even though we're not actually creating the VPN. So we're going to do a very similar thing with the IGW. We're going to create the virtual private gateway. Okay. And you can see that it does run BGP, or is it capable of running BGP at least. And so you can use the Amazon default ASN, which is a private ASN, I think like 64512 or something like that. Or you could do a custom ASN just depending on your preferences and your needs. I'm just going to use the default one. Yeah, 64512, you can see. My next step is I'm going to need to associate it again with a VPC. So I'm going to, oh, it's still in a pending state. We've got to wait until, there we go. Now it's available. So I'll select it, attach to VPC, and it's attached. And that's all you can really do on the VGW, right? It's very similar. Let's come in and create a customer gateway, right? Now, just recall, a customer gateway is an object that Amazon or AWS is going to route with, share a routing process with, but not directly control, right? It's a gateway for the customer. So let's go ahead and create a customer gateway. Give it a name. So BGP ASN, basically, I wouldn't make it the same ASN as your VGW. I'd run eBGP here. In fact, I'm pretty sure you have to. I've never tried running iBGP, but I don't think it'll work. So whatever ASN you're going to have on your device is fine. So if it's a net new device, you know, you could go with whatever their suggestion is possibly. However, if it's already running BGP, you would want to use that, right? So this is my customer gateway external interface. It needs to be a public IP. It doesn't have to be a public IP, by the way. It's really whatever IP is going to terminate the VPN. So that could be a private, right? If I was building like an overlay between two VPCs, for example, I might have a private. But in the most common use cases, it's a public, right? So I don't know. I'm just going to make up. This is definitely not my IP, right? You could upload something like a cert. You could give the device a name, like the host name of the device. I'm going to leave those blank for right now. I'm just going to go ahead and create the customer gateway. Great. So here's my customer gateway. Once that's done, so now I have my VGW, right? I have my CGW. Now I could create a VPN connection. So we'll, just as always, we'll give it a name. And I'm just trying to stay consistent with the name, right? You should really come up with your own naming standard. We're going to leave it on a virtual private gateway, right? We're going to select the only one we have in the region, right? It's an existing, you could create, by the way, the customer gateway in the same step. I usually pre-create them. So here we go. I'm going to say that I'm running BGP, but you can see that we could do static, right? Pre-shared key. So I'm just going to do this in standards. You could use secrets manager, which you would probably want to do something like that as a best practice. I'm not going to do that for a demo. And then, so this is, when it says local, it really means local to the CGW, right? So what do I have on-prem? So maybe I have 10.0.0.0/8, right? And then this is what's local on the AWS side. And we know that that's 10.1.0.0. And I think /25 takes up both subnets. Right? So I'm only going to allow my private subnets across this. And that's about all I have to do. However, I want you to be aware if you need to edit tunnels or have specific tunnel settings, you can set them up here. Some tunnel settings can also be changed post-deployment. I'm going to go ahead and hit create VPN connection. Now, again, this will create it on the AWS side, but it's not really doing anything, right? It's in a pending state. We need to wait for this to go into active. I'm just going to show you how to download a configuration. And there is no requirement for your customer gateway to be reachable. You can do these asynchronously, right? In fact, I just did a large project for a customer where we had to do hundreds of these VPNs. And we pre-built them, and then we built them on the other side and cut them over so that we kind of control, right? We kind of control when it's going to happen. I'm just going to go ahead and pause here until it goes into active mode. Okay, it took a few minutes, but it eventually did, as mentioned, go to a state of available. I do want to point out, available does not mean that the VPN's up. And in fact, if we click into tunnel details, you'll see the VPN status is actually down, right? So what it means by available is it's available to be used. You can now go configure your customer gateway side, and in theory, at least, it can transition from a down to an up state. And when you do, by the way, when you go configure the other side, it will also add in a column for BGP. so you can check the BGP state as well. We don't have any of that configured currently. I want to show you what the download option looks like. You can come in here, you select your vendor. I'll say Cisco just because that's what I'm most familiar with. I do a lot of CSRs or Cat 8 KVs, so I'll go ahead and select that, right? I'll change my IKE version to IKE v1, and I can click download, and it will just download a text file for me. Now, I want to point something out. Number one is a lot of the firewalls, you will find that they don't support an IKE version other than IKE v2. So this is a best practice you need to be aware of. Most of them will support IKE v2, but they may not have a pre-built template for IKE v2. So you may have to download the IKE v1 template and then manually go in and edit the config file that they give you to switch it to IKE v2. You don't want to be deploying VPNs in IKE v1 any longer. This is just Amazon not quite keeping up with as things change. And the VGW in general, I find, is a somewhat dated concept. It hasn't grown very much with the rest of the industry, I would say. Like I said earlier, it's limited to 1.25 gigabits. You'll see that a lot of these pre-built configs are going to be IKE v1. However, what you're going to find is they will support IKE v2, just not in the pre-built template. Once you download it, you never want to just paste it in as is. Anyway, you're going to want to go in and update it. Like, for example, when it creates tunnel interfaces, what if the tunnel interfaces it creates are already in use on your customer gateway? You need to go in and change those things. So you're always, another recommended best practice, you're always going to want to come in, once you download it, go into the text file and update that. And we have one more gateway object to create here, and that's our NAT gateway. As I mentioned in the drawing, I have two NAT gateways for redundancy. We're just going to create one because we're just doing kind of a demo today. So we'll go ahead and give it a name. We'll pick a subnet. Now, the NAT gateway is going to want to go in a public subnet, right? Hopefully that makes sense. I'll pick subnet 1 that's public. Now, this is interesting, just so you're aware. The use case we're looking at today, and probably the use case you look at most frequently, is a public NAT, but you can do private NATs, right? So think about, for example, if I was going to do some kind of a connection between two VPCs that have overlapping CIDR blocks, right? Maybe I'm going to build a VPN or something like a overlay or something, but I've got two that have overlapping CIDR blocks. I could do a private NAT gateway, for example, and select a small subnet that, the other side maybe assigns me. Maybe they give me a /28 or something like that. And I could put the NAT gateway there, but most commonly it's a public, right? So you will see, so there's this concept of an elastic IP. We talked about this when we talked about NATing in general. And I always recommend elastic IPs over auto provisioning public IPs, right? So we don't have one available yet, so we'll just hit allocate. Okay, and when I hit that, you'll see it tells me what the IP is, and it automatically adds it in over here. There are additional settings here. For example, I'm going to leave that all blank. I'm going to go ahead and create my NAT gateway. Right. We don't need the other gateways. You'll recall we had to kind of basically attach it to, or sometimes I refer to it as tag it into the VPC. We don't have to do that with the NAT gateway because it's a subnet level object, right? A NAT gateway exists within a subnet. A subnet doesn't exist without a VPC, so there is no associating a NAT gateway with a VPC. It's already done because we deploy it into a subnet object. Now we will see that it's in a pending state. It shouldn't take too long and it will go active. It will take a little bit. The only reason why is it's got to, in part of the same step, is go build out that Elastic IP. And I just wanted to point out now, it took a little bit, but our NAT Gateway is now available, right? So you could click there, or I like clicking into the objects myself typically. And you can find your public IP, your private IP, all that kind of stuff. This will all be deleted before this goes live on YouTube. So please don't try to connect to these. They'll be long gone. So now we have everything we need. All of our pieces are in place to start doing our routing table. So let's hop over there. So here we are on the routing tables. You'll see that the only routing table that exists currently is the main routing table. And you've already heard me drone on that I don't like using the main routing table and why. So we're going to move directly to creating some new routing tables, right? So we'll go with net.academy. Okay. We will select a VPC, right? Okay. And then we're going to go ahead and we're going to explicitly associate the public subnets, right? So we're going to edit these and we're going to pick the two public subnets. There, our public route table is built. Let's go ahead and add a default route. That's the only route going into our public, right? So we select default. What do we point it to? We point it to the IGW, right? So we select Internet Gateway, and then we select the Internet Gateway that we earlier attached to the VPC. And now we save our changes. Okay. Let's go create a second route table, the private route table. We will select a VPC. We will create it. We will make a subnet association with the two privates. Okay. And then we're going to add routes. Now we're going to add two routes on this one. If you'll recall from the drawing, we're going to add a default route. And what does it point to? It points to our NAT gateway that we created. And then we're going to add a 10.0.0.0/8. And we're going to point that to a virtual private gateway. And we select our virtual private gateway. Now, for that route to actually work, it'll take the route without a problem. But for it to work, we would have had to have configured and successfully brought up both the IPsec tunnels and the BGP, right? So this is kind of a dummy route. Okay. And there, now we see that I've got all of those routes, right? So I've got a default route pointing to our NAT gateway, and I have a 10/8 route pointing to our VGW. Okay. Hopefully you got something useful out of that demo. I know I did. I always enjoy refreshing those skills myself. Even though I spend most of my days working with AWS, it's sometimes nice to get back to the fundamentals. And as I mentioned, not every account is going to do this public-private concept, or not in that particular way. So it's kind of nice for me to go back and kind of refresh those. All that being said, I do want to thank you for your time today. Hopefully you're getting something out of this AWS course. Let us know down below what you would like to see covered, or if you have totally different topics that perhaps we can cover. It doesn't have to be me. It can be one of my coworkers, right? So you can let us know down below. And as always, if you're enjoying the content, why not give us a like and a subscribe? It does help out. We're trying to get the channel kind of off the ground. So any movement you can help with is appreciated. That being said, have a great day, and I'll see you when we cover TGWs next.